Hey guys, welcome back to another GCSE Maths video. So paper 1 is finally finished and I heard that it was a very weird paper. I've had a look at it myself. It was very unique, it was very weird in terms of all of the 5 markers that were there and in terms of the topics that didn't come up. But we just have to focus on paper 2 now. So once again, we're doing these 2025 aiming for grade 9. This time it's paper 2. So this is all of the different topics that last year's year 9s, grade 9s, really struggle with. Once again, if I show you just the mark scheme part of this is a 36 mark paper, so the average grade 9 student last year managed to score, let's say, 25 marks on these questions, so that's what you're kind of aiming for. Grade 8, 14, grade 9, only 9, which is interesting, that's only a quarter of these questions right, and then it kind of gradually goes down, so if you want to pass, just get 2 marks. Now there was some confusion when I said this in the last video. It doesn't mean that if you get 9 marks on this paper you've got a 7, obviously that's not true. Instead, it just means the average student who got a grade 7 last year scored 9 marks on these very questions. So you can kind of compare yourself to the standards that last year had. But without further ado, let's just jump straight into it with the first question. In my opinion, this is probably the hardest bounds question that's ever come up, or at least this style of bounds question is definitely one of the hardest ones that has ever come up. And the reason for this is, it says here, by considering bounds, so we know we're going to do bounds, calculate the value of t to a suitable degree of accuracy. Now this is something that some of you might do in the future if you go into science or engineering or something like that, where you will round to a suitable degree of accuracy, so this is somewhat useful for some of you. But then it says you must give a reason for your final answer. Now this is a 5 mark question. Now I'm going to show you how to get some of the marks. The first thing that you always want to do in any bounds question is you want to write out the upper and lower bound for everything. The reason for this is you normally get 1 or 2 marks for this. So even if you're unsure, you at least get 1 or 2 marks instead of 0, which is, you know, a lot nicer. So with W, if we rounded this to the nearest 5, then the thing I do is I half that number, so it's 2.5, and we're going to add and subtract it. So 437.5, and then subtracting it, 432.5. And then with A, it's correct to the nearest 2 significant figures. Well, if we look at what the second significant figure is, it's a 0.8. So we're going to half 0.1, so that's 0.05. And we're going to add and subtract it just like before, 8.5 and 7.5. And then lastly, we have C, which again is 2 significant figures. So we're going to add 0.05, so that's 2.55. And we're going to subtract it, 2.45. That right there has gotten us, well, just 1 mark in this question, but I've seen it give you 2 marks in others. Now, what do we think it means? Calculate the value of t to a suitable degree of accuracy. Well, what it means is, because W, A, and C have a range of values they could be, they have upper limits and they have lower limits, then the value of t also has a higher value that it can be and a lower value that it can be. So for example, and that's what we're essentially working out, by the way. So we're going to find the biggest possible value of t and the lowest possible value of t. That's the goal here, because we want the range of values t can be, so that way we can actually round it correctly. So the next thing we do is I'm just going to write upper t and lower t. Again, laying your work out nice and neatly will help your examiner give you those extra marks. Not even extra marks, just make sure they give you the correct number of marks, but also it helps your brain stay organized as well. So now if I want the biggest value of t, what do I want? Well, if I want to make this value of t as big as possible, I want the biggest value of w and the lowest value of the denominator. So I want the upper value of w. But if I want to make the denominator as small as possible, well, this is a take away c. That means I want a to be as small as possible and c to be as big as possible. Why? Well, think about it. Let's say we say a is 9. If we make c a small number, like 1, we get 9 take away 1 is 8. But if we make c a big number, like 8, 9 take away 8 is 1. So if we want to make the denominator as small as possible, we need the smallest first value, and we want to subtract the biggest thing from the second value. So that's what we're going to do. And once we work this out, by the way, this, by the way, would give us a mark. If we do the same thing with the lower bound, that gives us another mark. So that's 3 marks in total. So we're going to do the same thing for both upper and lower value of t. That gives us 3 out of the 5 marks. So that means t is just equal to the upper value of w was 437.5. The lower value So the upper value of, so yeah, the lower value of A, which was 9.75, and we want the upper value of C, 2.55. So I'm going to shove this all on my calculator, and I'm not going to round it at all yet. I might do later. In fact, I'm going to put a little up arrow to remind me that's the upper value of T. I will round it at the end. So 437.5, 9.75, subtract 2.55, gives me probably kind of a long number. Yep, and I'm going to write the whole thing down. Because I've seen people round this a bit too early, and then they get the wrong answer at the end because they don't spot something later on. Now for the lower value of T, you could think about it. So I want the lowest value of the numerator, the highest value of the denominator, or we could just swap the directions of all of these. The lowest value of the numerator, okay, that makes sense, so lower value of that. But now we want the biggest value of the denominator, because when we divide by a bigger number, we get a smaller number. So we want this thing to be as big as possible. That means we want the biggest value of A, the smallest value of C. Again, we've just swapped the direction of these over. So that's another way to do it. And let's write it out. So we have T equals the lower value of W is 432.5. Okay. Upper value of A, 9.85. 2.45, the lower value of C. So instead of pressing on and getting rid of this, if I just go through, I can actually just edit the numbers. Saves me a little bit of time. I get 58.4 for blah blah blah. Okay. Now, that's 3 out of 5. The question is, how do we get the last two? Well, we haven't actually found T to a suitable degree of accuracy. So what does that mean? I've got the upper and lower limit for T. Now, if you notice, whenever I do, for example, A, I can round that to two significant figures and get 9.8. Right? That's the whole point, because we have the upper and lower bound, and then when we round it, we get the value in the middle. So here, I'm going to compare these two numbers, and I'm going to see to what decimal place or to what significant figures do they round to the same number. So for example, if I do it to 3SF, this is 60.8, that's 58.4, they're not the same. But if I round it to 1SF, they are both 60. So T equals 60 to 1SF, and the reason is simple, because they both round to 60. Both the upper bound and lower bound round to 60. Now, the thing I didn't like about this question is the fact that you round it to 1SF. In other questions that I've seen like this, it's normally 3 or 4 SF, 2 or 3 decimal places. So again, it might not just be 1SF. It might be something like four significant figures or whatever. But you check where they both round to the same number, but you want it to be as precise as possible. Okay? Because to 1SF, they'll always round to the same number. But they also might round to the same number at 3SF. That means you want 3SF. So be careful with that. So this question is, of course, similar shapes, because it tells me they're similar. I know, I'm a genius. However, they give you maths, and this confused quite a few students. Now, if you think of your physics knowledge, and your maths knowledge, I suppose, remember that density is mass over volume, which means mass is density times volume. Now, because they're made from the same material, this means that mass and volume are both proportional to each other. So, for example, if I double the volume, I double the mass. If I triple the volume, I triple the mass. But also, if I triple the mass, I triple the volume, because they're the same material. So the mass and volume are directly proportional. So this right here is actually what you're going to use for your volume scale factor, because it will be in the exact same ratio, the exact same proportion as each other. So that's how you do this question. Now let me take you through the rest of it. I'm going to show you how I do it. So the first thing I would do is I would lay out LMP, and I like to have some kind of, I call it a table. And we're going to have the volume, we're going to have the area, and the length scale factor. Ooh, I just realised, you know what, let's call it the height scale factor, because I've already got an L there. And I never take 2 L's, ever. So, now we just fill in the information. So, L is 64 for the volume, or the mass, if you really want to call it the mass. 125 for M. M has a surface area of 144. and P is a surface area of 16. Now we want the height, the relationship between the height. So what we're going to do is we're going to go from volume to height, and we do that by cube rooting. So that would be 4, and that would be 5. And then we also want to go from area down to length or height, whatever you want to call it, which is square rooting. So that gives me 12 and 4. Now, all we want to do in this question is combine this into one ratio. So what happens when you have two different ratios? Well, all you need to do is you need to make their common value the same. So in this case, we have m for both of them. We want to make them the same number, so I'm just going to times them by each other. So I'm going to times the first one by 12. That gives me 48 and 60. And I'm going to times this one by 5, which gives me 20. So that means, does it say in the simplest form? It doesn't even say in the simplest form, so we don't actually need to simplify this. We get 48 to 60 to 20, but if you did want to simplify it because you are bored one day, that's 12, 15 and 5 if you divide by 4. That's 4 marks. That's really, really good. Now, just so you're aware, cube rooting gives you a mark. For this, square rooting gives you another mark. Making the ratios kind of the same, and then for getting the final answer, 4 marks. Really quick, really nice. Well, just to pre-warn you for the rest of these questions, like there's a lot of proofs in this, like a lot of geometric proofs in this. So here we have A and B are points on a circle centre O. MAP and NBP are tangents to the circle. Prove that AP equals BP. So these two lines are the same. This is actually technically proving a circle theorem, because remember there's a circle theorem that says tangents from the same point are always equal in length, but whatever, right? So what would I do in this situation, especially if I didn't know what I was doing? Because personally, I've actually never done this proof before. I don't know if I should admit that, but I have never done this proof before. So when I was looking at this, here's what I would do. The first thing is, I would start labeling stuff. So for example, OA and OB are both radii, which means they meet at 90 degrees to the tangents, which by the way, it says that would give you some marks in this. Now I remember that this oval shape is actually a kite, which means if I split this in two, you know, I tried my best, you know that, look at this. Alright, I tried my best. If I split this in two, these two triangles should be congruent. So this is actually a congruent triangle question. Now, how can I prove this? Well, this is a right angle triangle, and if you remember the RHS condition, is if it's a right angle triangle with the same hypotenuse and one side the same, it means the other side has to be the same as well. It means all three sides are the same. So, and that's because of Pythagoras, right? Because you're going to do the hypotenuse squared minus the same side squared gives you the third side. So, how can we prove this? Well, first of all, OP is a shared hypotenuse, right? So both of the hypotenuses, hippopotamus, will be the same. Then we have two right angle triangles, so OBP and OAP. And lastly, OA and OA equals OB equals the radius. Therefore, triangles OAP and OBP are congruent due to RHS. This means that AP and BP have to be the same, because if we're saying they're congruent, we're saying the two triangles are identical, that means their third side has to be the same. Therefore, I forgot the letters were. AP and BP are the same. There you go. And that all stems from just the right angle triangle thing, so making sure these are right angles. So I don't think that was actually too bad. That's 4 marks, but you have to be very clear. These are C marks. C means that you're actually giving specific reasons for each step. It's like an explain question in science. You have to actually write something properly out. Unfortunately, just labeling it doesn't always get you the marks. Sometimes it does, but you know, I wouldn't risk it. I'd always write it down as well, just in case. Good old-fashioned 3D shapes, right? Everyone loves these. Not really. I despise them. So, VABC is a pyramid. ABC is an equilateral triangle. Cool. M is the midpoint. Cool. F is the point on MC, such that it's in the ratio of 1 to 2. Label that slightly. V is directly above F. Cool. VF is 8 centimeters. VCM is 52. Work out the side length of the equilateral triangle. So we're trying to work out one of the sides. Now, what would I do? The first thing I would do is I would draw out 2D triangles. I don't know why I said 2D triangles. Triangles are always 2D. But I draw out 2D shapes that illustrate this information. So for example, I'm going to draw one. That's VFC. That's a big triangle, right? So let me just draw that out here. Now, how do I know this is right angle? Well, it says point V is directly above F, which means it must be at a right angle to F. And I'm going to label that's 52 and 8 centimeters. Now, I've actually spotted what we need to do next. Now, we want to work out the side length of the equilateral triangle. So why don't we just, why don't we just draw out the equilateral triangle, right? Why don't we just draw it out? So if I draw this, if I'm looking straight down, that's, thank God for autocorrect, put it that way. V, C. I'm actually going to leave this for a second. All of these are equal lengths. And if I draw in the middle part, so we have M, we have F as well, and we know that ratio is 1 to 2. So maybe you can see what my plan is now. Now that we've illustrated now that we've drawn out, I guess illustration is drawing out, the actual shape, you might be able to spot what my approach is now. So I'm going to give you a second to think, and then I'm going to go through it really quickly. So, here's the goal. If I work out the length F to C, that means I can work out the length C to M, because I can just use this ratio. Because F to C is 2 parts in this ratio. So I can quickly work out the full thing. Then, because all of these sides are equal, let's call them X for example, I could make this a right angle triangle because it will split straight down the middle. So let's call that MCB, where that's X over 2, and that's X, and I can use Pythagoras to work out the length of that side. So that's what we're going to do. So first things first, we have, if we look at this top triangle, we have the opposite side, that's the hypotenuse, and this is the adjacent. So I'm going to use O and A, so that's tan, because of SOHCAHTOA. So we have tan 52 equals opposite, which is 8 over the adjacent side that we want, which means the adjacent side times both sides by A, we get A tan 52 equals 8. So A is equal to 8 divided by tan 52. So let's quickly whip out our calculator. I'm in radians mode because my calculator hates me. So shift, menu, angle unit. How did I tell? By the way, there's a little R here. Now there's a D. That's what I want. I don't want the R. So you need to check that in your calculators as well, because if you do everything in radians, you're going to have a bad time. And you're not going to be able to tell. That's 6.25 for the adjacent. So if we go down now, over here, we have the ratio of 1 to 2. This part is 6.25. So what I'm going to do to work out the total length is we have 3 parts in total. So 2 parts equals 6.25. I want to get up to 3 parts. So how can I do that? Well, I could divide by 2 to find 1 part and then times by 3. And because this is a calculator exam, I don't have to do anything fancy here. I can just press divide by 2 times by 3, and there you go. Let's call it 9.375. I want to keep it relatively accurate. And that's the length of C to M. So 9.375. And now we have Pythagoras. So we're going to say that a squared plus b squared is c squared. So we have 9.375 squared plus a half x all squared. Don't forget, it's not half x squared. It's going to be a quarter x squared because it's the whole thing squared equals x squared. Jeez. Here's what I'm going to do actually. I'm going to leave this as a squared because I really can't be bothered to write out something disgustingly long. That would be a quarter x squared equals x squared. Then we're going to move this over. So 9.375 squared equals 3/4 x squared. Why? Because it's x squared minus quarter x squared. Then all we're going to do is times both sides by 4, divide by 3, and square root. So x is equal to 4 times 9.375 squared over 3, because again we have to times by 4, then divide by 3, and then square root. Again, it's a calculator paper, right? Okay, calculator, and it's 1 decimal place. So let's see. We're going to do square root 4 times answers squared over 3. Gives me 10.8 centimeters, or whatever it says. 10.8 centimeters. There you go. 3 marks. That's kind of long. I'm not going to lie to you. There might be a faster way to do it, but that's the way I was thinking. In fact, I'm looking now, you could probably use trigonometry as well, because you know that's 60 degrees and you know that length. So you could use trigonometry as well. Very interesting. Probability equations, I think that this is quite likely to come up in paper 2 or 3, I'm not sure which. Because there are actually 2 ways to do this. One of them involving fractions, shockingly, I know. But like fractions with fractions, and I don't like that. So I'm going to show you a slightly better way to do it. Now, it says there are only red counters and yellow counters in the box. 3/5 of them are red. So what I've seen people do is they say that the red then equals 3/5 of x, and yellow equals 2/5 of x. Now, for me personally, I don't like this, because then you have fractions and fractions, and then it gets all mixed up. Instead, what I would do is, I don't know how many there are in total, so instead I'm going to say each part, right? Each part, so if you want 1/5, each part is x. That means there's 3x for red, and for yellow there's 2x. And that removes all of my fractions in this case, except the actual algebraic ones. So if you take that random 2 counters from the box, the probability that they are the same colour is 41 over 80. Work out the number of yellow counters in the box. So I'm looking for 2x, essentially. So, same colour means either she gets both red or she gets both yellow. And because we're saying or, that means we have to add them up. So, let's do that. So the probability of getting a red the first try is, actually I should write, that means the total is 5x. So getting a red first try will be 3x over 5x. And then getting another red, well, there'll be 1 less red, 1 fewer reds, and there'll be 1 fewer in total. Then we're going to add yellow, so we get 2x over 5x times 2x minus 1 over 5x minus 1, and this should apparently equal 41 over 80. Now, just so you're aware, getting a correct probability gives you 1 mark already, and then a correct product gives me a 2nd mark, and lastly, for the equation, 3 marks. So I've gotten 3 of 5 marks just for doing this. 3 out of 5. So it's 3 marks in about, what, 45 seconds? Really, really quick, really, really good. This is a 5-mark question in total, so even if you aren't sure how to solve something like this, getting 60%, you know, if you average 60%, you're looking at between a grade 7 and an 8. That's not bad. That's not bad at all. So you don't have to be able to solve this. So, how do we solve this? Well, what I would do is I would not expand the brackets yet. Instead, I'll just combine these fractions. So if you notice, they have the same denominator, right? Because it'd be 5x times that. So I'm going to make this one big fraction. We get 5x minus 1, right? Because both of these denominators are the same, we can add them. And then again, I'm not going to expand yet because I don't want to. I've got the best excuses ever, don't I? 2x minus 1. That doesn't look good. Equals 41 over 80. Now, let's expand and simplify the top just to keep it nice and easy. 3x times 3x is 9x squared. 3x times minus 1, minus 3x. 2x times 2x is 4x squared. 2x times minus 1 is minus 2x. Again, I'm not going to expand. Actually, yeah, let's do it. Now I'm going to cross multiply. So that gives me 80. And then if I simplify the brackets, I get 9 plus 4 is 13x squared minus 5x equals 41 times all of that. Dear God. Now we just need to expand and simplify. Yay. Oh, this is so much fun. You know what? I'm using a calculator. No one can stop me. 80 times 13. Yeah, that's exactly what I thought it was. That should be 400, right? I'll lose all. Yeah, there we are. It's 400x. 41 times 25. Again, I'm still using a calculator, by the way. I'm not even going to pretend that I'm not. That's 1025x squared. And then 41. Actually, wait, this is going to be 205. Yeah. 205x. Move everything over to the left-hand side, so we get 1040x squared minus 1025x squared, which is 15x squared. Yeah. Then we get minus 400 plus 205, which is 195, minus 195. So if I factorize out an x, we get two options, right? X equals 0, which is obviously BS. It can't be 0, right? Because that means there's no counters. So it must be the other option, which is x is equal to 195 over 15. I'm not going to lie to you, that should be something I know. But yeah, 13. That's not my answer. It says how many yellows are there, which is 2x. There are 26. There you go. That's fun, isn't it? There are 10 football teams in a league. Each team plays every other team 4 times. Interesting. Work out the total number of games played. So here's what we're going to do. I'm going to ignore the 4 times for now. I'm going to say, what would it take? How many matches would have to be played for them to play each other 1 time? Now, if we imagine, I'm going to scale this down a bit. I'm going to have 4 football teams, okay? Actually, let's have 5. Why not, right? Now, if you think about Team A, how many other teams will they play? Well, they're obviously not going to play themselves. They're going to play Team B, C, D, and E, right? So, A, B, A, C, A, D, A, E. Cool. So then you might think that the way you work this out would be 5 times 4, right? Because we have 5 teams, and each of those teams will play the other team 4 times. So A will play B, C, D, E, B will play A, C, D, E, C will play A, B, D, E, and so on. But there's a problem. Look what happens when I write out the teams that B will play. If I write out the teams that B will play, you will get BA, BC, BD, BE. And if you notice, look at that. AB and BA are the exact same match. So that means that isn't a unique match, which means I don't want to count that twice. So in actuality, each team will then play 1 fewer teams as they go along. Now, there are 2 ways to kind of work this out in terms of not having to, in terms of not counting the same one twice. The first one is you could just divide the answer by 2. That just happens to work. Or if you really want, you could do 5 times 4 for A, plus 5 times 3 for B, plus C, and then so on. But that's kind of long. And then because they play each other 4 times, we would times our overall answer by 4 again. So if we replace that with a number we have 10 times 9 over 2, so that's 45, times 4, which gives us 180. That's your final answer. So again, we have to half it so we don't double count. We subtract 1 because a team doesn't play themselves. And then we times it by 4 because they each play each other. They play 4 times each other. Here's a very typical question, especially if you guys want to go into A-level maths as well. This actually comes up. So we have P, Q, and R. And again, I would recommend you drawing this out really quickly. So we have minus 4, 5, so that's point P. Then we have 6 minus 6, so somewhere down here for Q. Then point R is like, I don't know, given that P, R, Q, so it's probably like up here somewhere. Given that that is a right angle, find the value of K. Well, what can you tell me about if this is a right angle? What does that mean? How does that help us? Well, it means that PR and QR are perpendicular to each other, right? They're perpendicular. And what can you tell me about perpendicular lines? Well, their gradients are negative reciprocals of each other, right? Or in other words, they times to -1. Both the gradients will equal -1. So let's work it out. So if we find the gradient of PR, I get something like this. So we're going to do K plus 3 minus 5, because it's difference in Y, right? K plus 3 minus 5. K minus minus 4 is K plus 4. So we get K minus 2 over K plus 4. And then we're going to do the same thing with QR or RQ. Let's do RQ. No, let's do QR. Let's do QR, because I've just realised. Okay. So we've got K plus 3 minus minus 6. So that's K plus... Actually, no. Let's write it out fully. Over 6. Over K minus 6. It was K plus 9. K minus 6. Now again, using this relationship in the top, if we times those two gradients together, they should give me -1. So I'm going to cross multiply again. So I'm going to move these two up here. So now we have K minus 2, K plus 9 equals minus K plus 4, K minus 6. Expand and simplify. That gives me K squared. That'd be minus 2K plus 9K, so that's 7K minus 18 equals minus K squared minus 2K minus 24. So expand that right hand side again. Minus K squared plus 2K plus 24. Move everything over to the left hand side and we're going to get a quadratic that we can then solve. So 2K squared plus 5K minus 42. Yes. Yes. And then all we need to use is, I'll just use the quadratic formula for this because it might not factorize very nicely, or it might factorize nicely, who knows. So yeah, let's just do the quadratic formula. So minus b, again I like to use plus minus, so b squared minus 4ac over 2 times 2. Gives me a value of 7 over 2. Or, and if you notice in the question it does say find the possible values plural, minus 6. This is because it could be positive, it could be negative, it doesn't really make a difference. And there's the 5 marks. It's not that long really, but honestly that is a bit tricky in terms of the problem solving for that question. So a bit of a different proportional question in this case. So we have a table of values here, and Nadia says that y is directly proportional to x because y increases by 4, x increases by 2. So it goes up in 2s, this goes up in 4s. Is she correct? Now directly proportional doesn't mean that they go up by the same value in terms of y and x go up by the same value each time, especially in terms of adding. What it actually means is that when you times one by, let's say, 2, the other one gets doubled. So when I double x, y should also double, which isn't the case in this case. The way that you can show that is simple. All you need to do is divide any two x values, so these pairs of values, and divide the next ones and show that they're not equal. So for example, when you have direct proportionality, you might have something like this. And then, if we keep going, for example, now if I divide these two values, you might notice I always get the number 2, because that's directly proportional. If I double one value, the other value doubles. But in this case, we have 4 divided by 4, and 8 divided by 6, and 12 divided by 8. None of those are equal. So they're not directly proportional. Okay, so it doesn't just mean as one goes up, the other goes up. They go up by the same amount. And now here we have like an actual different, the usual style of question for 3 marks, and I'll show you where you get them. W is directly proportional to the square root of t. If you just write W equals k square root of t, that's 1 mark. The second mark is for working out k using the information they give you. So W is 140 when t is equal to 64. So that's 8. So 140 equals 8k. So divide both sides. So half it again. That's 20. You know what? Screw it. What am I doing? It's 17.5. But yeah. That's the second mark. And for the last mark, it's for working out W when you get the value. So W equals 17.5 times the square root of 7.84. And that's it. 3 marks. Really nice. I love proportionality questions like this, because 3 marks is a lot. It's quite a bit. And it's honestly not that bad. I think that anyone can really do it. Oh, 49. Look at that. How nice. 49. Very nice. And lastly, it says sketch the graph. Now, this is a bit tricky because you're actually drawing the graph of square root something. So it's going to be something that looks like this, and it not levels off completely, but it decreases quite quickly. This might be one of the quickest proofs I've ever seen, but it is hard to kind of start. So the first thing, it says that BA and BC are the same, so let's label that. But what are we trying to prove? We're trying to prove that OB bisects ABC. So what I would do is I would draw a line going from here to here. And then think about what I'm trying to prove. I'm trying to prove that these two angles are the same. Because if they're the same, that means it's been bisected, right? Well, I can actually create 2 really nice triangles like so. And the reason why I thought to do that is I know that O to A and O to C and O to B are all the radius. So now if I prove that those 2 triangles are congruent, I'm done. Well, first of all, OB is shared between them. Then OC and OA are equal because they're the radii. And BC and BA are equal because it tells me that. So that means that's SSS. So they're congruent. This means that OBC equals OBA because the 2 triangles are congruent, right? Therefore it bisects. Because again, if those 2 angles are the same, then that means it must have been bisected, cut in half. That brings us to the end of it. In all honesty, like the actual length of the questions and the difficulty wasn't that bad. The main problem is the thought process, and I think that's why these proofs went quite poorly for people. This graph went quite poorly as well. This also went poorly. This bit went pretty okay. This was a hard one in terms of the actual process, to be honest. But again, even the ones before that, it's... Okay, this one again, hard process. Hard process. But in terms of these proofs, it's more of a thought experiment more than anything. But again, I hope this helps you with your revision. Do focus on doing those hard exam questions and trying to practice them and understand them. And I'll see you in the next one.